Hello, hello. Now it's a good time as ever. I'm on time and I think everything is working. I'm just checking in audio. Should be all right. I'm just going to listen to my voice. Yeah, it is working. So great. Welcome. It's been a while since I've been streaming and it's been a while since I've been dealing with NodeRED. So I'm super excited to actually do that. I've been doing stuff in the background, hence not as frequent releases. I have lots of stuff that I want to talk about. I have lots of stuff on my to-do list and everything is half done. So don't worry, I'm not going anywhere, and this year is going to be probably the busiest ever and the most exciting ever. There's lots of interesting opportunities ahead. But I'm finally starting to get around the idea that I can start automating this place, apart from innovating. And well, it's a daisy chain of things. I think the biggest problem that I didn't anticipate, you might be better at this than me, is that everything when it comes to owning a house and doing stuff has a chain of priority. You set yourself up to do a thing and then you discover that there are 3 or 4 different things that you should do first in order to make it less costly, more efficient and just better. And I think I'm a victim of that. So at the moment while I'm supposed to be dealing with the heating, excuse me, I discovered that, well, I have a solar panels that kind of feed into the grid. And yeah, I needed to do something about it in order to take that advantage, because those solar panels aren't actually mine. They are on the lease. And if I can show you around with this, so let's introduce my new house a little bit. So this is my new house, the one with the silver car in here. You can see me standing in the background in there, and I'm just kind of flying a drone to inspect the roof. And you'll see the solar array panel, which consists of 14 panels in here. Now, these panels are 245 watts each. Oh, shit. You can't see this. Let me fix this really quick, okay? Damn it. Okay, this way. That now you can see it. Okay, so again, this one with a car in here. That's where I'm at, and yeah. So you'll see at the back that I have a solar panels. I've been filming footage with a drone to inspect the roof, inspect the panels, and do a little bit of surveying there. I wanted to map entire back garden to kind of figure out the layout. So I have a 14 panels on the roof, which 245 watts each, for the total of 3,500 watts in peak power or ideal power. Obviously, that will depend on how much lights I get, and those are not my panels. They are leased. Leased meaning that the company put them on the roof. I get the benefit of free solar panel electricity, but the excess of it is being sold to the grid. Now it's winter, solar generation isn't that great, and I've been kind of trying to figure out what could I do with this. And the first thing to kind of like figure out is to see how much electricity we're dealing with and whether it's worth it. This array it isn't young. I think it's been mounted in 2010, so it has several years in its belt, and you can get more efficient panels, better panels, which is something I would probably look into in the future. So as it stands right now, when it's really sunny in UK, during the winter and the peak hours, I can get 1,500 to 1,700 watts of power from the sun feeding into my home. That is all in dandy if you want to power a computer, but if you want to, like me, consider a dual fuel heating. Dual fuel heating meaning that the same radiators can be operated via gas or electricity, then I probably would end up with 1 or 2 heaters working, and that's probably just not quite there. However, obviously you don't make changes in those installations without any particular reasoning behind it, and since this is not a change that's going to be, you know, supposed to be beneficial straight away, my plan is that over the time replace those panels with more powerful panels, and I've seen some of the panels that can bring up to 600 watts for totaling 8,000 watts of power, and that would give me estimated electricity during the peak times in winter around 4,000 to 5,000 watts, which is suddenly something I could actually use to preheat the home when I'm at work, because peak times are unfortunately when I'm working, And when I get home, ideally, that power will be conserved for me to use in heat, basically turning my home into a bit of a battery. Now down the line I could deploy proper batteries to make it happen, but that's the situation I'm facing now. So in order to actually measure all of that and figure out how much electricity I've got in these panels, I needed to do some changes. I needed to go to my electrical box and add measuring devices to it. So that's what I did last week, and it was incredibly fun. And by incredibly fun, I mean that, oh dear. As soon as I turned off my house supply, my house power supply, I faced with one thing, my alarm going off, and I wasn't able to turn it off. So that's not ideal, obviously, and I was working under pressure. Can I do it this way? And let me share a different video with you. Done. Okay, I should be able to see this. So I was working under pressure, and every time I would turn off the house supply of power, my alarm would go off. So in here, you'll see my current electricity supply. Don't judge me, I didn't do this. It's not perfect. I'm probably gonna end up replacing all of this. So you'll see that the main electricity feed comes in here, goes through the meter, then it has a main cutoff power supply in here, and it's being split into two kind of sections. One goes below the box to the EV charger, which has been ripped out from the wall when I bought this, and the second one goes into the distribution box inside. Now panels feed throughout this feed in here into the box, and they go into that big cutoff panel cutoff switch in the middle, allowing me to cut off the supply, and they feed into the same electrical box, meaning that any excess that is being distributed in the house or sent back to the electricity company. So that is all in dandy. Now what I did was modify the box underneath it to allow me to actually get inside. I've got a question. Can you actually see what, because this is not, okay, that's fine. And my preview wasn't live, that's fine. Okay, sorry. Okay, so let's, can I go like live? Yes, okay. So I can see the preview of stuff, right? Okay, I think that now I'm all up to date. So this is Shellt 3EM, which I'm using. And basically it's a small device that uses Wi-Fi and has 3 clamps, or up to 4 clamps that is connected in here. I've put extra breaker in here with 6 amps. So this was fitted in for electrical circuit to charge the car, but it's no longer in operation. So I use that to kind of feed in the tariff and split additional wire from my grid to allow those phases to be fitted into Shellt and provide you with very accurate readings. And then I wrap the clamps on the live, on the neutral from the grid, and I split one from the electrical supply of the solar panel, and I ended up with measuring. And what do I measure? Let's show you what it looks like. So currently where is this? Currently, this is the graph that I've got. It's very quick. It's not very, how do you say it? It's not very elaborate, and this is something we're going to be dealing with today. So I've very promptly made a chart, and let me explain the chart. The green, obviously in here, this is a solar generation. Can I make it bigger? Not sure if that helps. So green, it's a solar generation. Overnight, it draws 2 watts to keep inverter running, which isn't that much, but that's what it draws overnight. And you see there is no generation at night. Now during the day, on this occasion, I had a 1768 watts. It was nice and sunny today, but the sun is quite low, and it just goes over the forest that you could see in my footage. Now that was the supply, and you can see that in standby overnight my house is drawing about 150 to 200 watts of power. So this is the standby consumption. It's a little bit high, and obviously I didn't optimize anything yet. I'll be using this chart also to optimize, to find out what is actually taking all that electricity and try to keep it to minimum. I'll come up with some interesting solutions, smart home solutions to mitigate that and make my house running as little as possible. So that's going to be interesting. But then you'll see that consumption actually goes down. So for example, in here, this 3000 watts of power. This is a kettle. You can see in here because I just made myself a tea as well before the live stream. And this is me making myself a tea. So that's how I know this is a kettle. I don't have a clue what that is. Excuse me. So the power draw is negative. That's how I connected the clamp, and it kind of makes sense to me. The only thing that I wish it was slightly separate on this one is that because where the clamp is located, it provides you with a grid usage, including, well, what's going to be a positive grid usage. This is, for example, how much electricity, the red one, it's being fed back to the system. So the biggest gap between green and red means that I'm using more electricity from solar panels for my home use and less feeding in. So ideally, I want that green to be as high as possible, and the red ones being somewhere above zero. That way I'm using that power to charge different devices, heat up the home, mine Bitcoin, however you're doing to use that spare electricity. If I don't do this, that electricity is being sold, and as per the lease agreement, I'm not making any money. That's the lease company that is making money. So that is the outline for now. Well, I have a preview of a chat, so if you at any given point have any questions, just go ahead and do it and just ask the questions. So right now it's not particularly elaborate, but that's what I've set it up. And in here I have two extra charts that it's not charts, gauges that show me the consumption from the grid and generation from solar. But those are the basic statistics I can get from NodeRED. And you can see this is my NodeRED test server, which I'm using right now. Let's zoom out to correct settings. And it's not particularly elaborate. That basically this is it. That's all it takes to create what I've just created in there. Now already in here I have some test stuff that I've started to implement. So these operations are writing to my Influx 2.x InfluxDB database that I'm going to use to store that information, because I want to have a historical data of what I'm using on the house and how I'm gonna make those savings. So right now I don't do any changes. I'm just gonna log it for a week or two until I have the good baseline over my house use without any smart tech. And once I'm gonna be adding new stuff, it's gonna be very interesting to see what savings I could make, how much it cost me to make those savings in electricity use, and whether it was worth it, basically. And I also started to play in here with the weather, because I want to make some predictions and start harvesting the weather data, because that's going to be quite helpful when it comes to estimating how much electricity you can generate per day, and then queue up maybe your Washington that day, etc., so you don't pay for that electricity that's being used by appliances. So that is a kind of an idea. Now, one of the things I've discovered recently is that you have Open Weather map, and I've done some tutorials for Open Weather app, and they come with APIs. Now, there is a very generous free plan that you can use to get some basic weather, but you can also get the Solar Irradiance Energy Prediction Service, which gives you how much energy your area is getting from the sun. And those is being split into historical data and predicted data. So it'll give you an idea of whether those predictions were correct and how that translates into your power that you get. Now, I don't know yet about, like, basic plan is like 1000 calls per day for free, but it doesn't include all of the data. And one of the things I kind of discovered, which is great, I was thinking, like, how about I would make a prediction based on angle of my panels and where they're facing and everything in the cloud coverage, and the irradiation data from from the website to basically estimate how much power I would get per day and take advantage of it. And turns out that they already have this. Now, if you go to somewhere here, you will find that there is an API documentation for solar prediction. There is one problem with that. Let's search for it. Where is this? Solar irradiance, solar panel prediction. This is it. So this is great because it will tell you a lot of fun things. So this gives you an insight to what you let's go to the actual output from it, because that's gonna be the most interesting bit. Where is it? Oh, come on, it's gonna be at the bottom probably. Ah, there it is. So once you input your peak power from peak power, location, azimuth, and whatever that you needed, it will give you a data that provides you with how much electricity you're actually getting from your panel, from individual panel. And those are based on the algorithm they've got. And this is a very useful information, very useful data. However, there is, and that would be awesome just to jump on that and use that. However, there is one problem with this. And the problem is that if you're gonna go to a pricing page, you'll notice that one call API you can get 1,000 calls per free, but that doesn't include that plan. You have to jump on a special plan, which is £250 per month. There's no way that's just not feasible to use that. As much as that would be super useful to kind of give you some information about what you can do per day based on the weather conditions and the panels you have, it's just expensive. However, I'll have an idea how to use the current irradiance data, which is not as expensive. I think you can get it with part of the one call API. So you would be free for 1,000 API calls, which roughly translates to one call every 2 minutes. It's more than enough. Then I can make a small device that goes spiral into our panels and tracks the sun and provides you with the same information. It's not going to be a prediction, but if you have enough of that information from the solar tracker, you'll be able to calculate that based on past predictions and maybe machine learning or something like that. But that is not what we're doing today. Today we're gonna get some little bit more information, and I mentioned I have Shelly 3EM. So Shelly 3EM looks like this. And it's a really nice piece of kit. It's quite accurate and it has lots of features. One of the best features, if we're gonna go to Shelly, So this is a panel from the Shelly right now, and one of the things that you can do, you can just go in here to Internet Advanced Developer Settings and enable MQTT, which basically will send that data to my server, and that's why I did. Now, if you do that, if you enable MQTT, you'll lose the cloud connection, meaning that you'll have access to this panel from the local network, but the Shelly app, which is quite nice and nice looking, is not going to be reporting anything, and that's fine. Now, you could bypass it if you're interested in having Shelly app and working. What you can do, you can just disable MQTT and get the output from this using just normal REST calls, because it supports that without disabling client. But for the sake of ease, I just use MQTT, because once I got it in my dashboard in here, I'm not that bothered about the cloud use, because I want my data to be presented the way I want. Hello, Smart Home Collective, welcome. Good, Andrea. Tell everyone that they should come and visit. Hello, Henrik, how's it going? Yeah, solar panels are a rabbit hole, and I'm like down the line, I'll be definitely considering whether it's worth of even having them tilted slightly, motorized or something. It's a thing, but for now, I just want to get that data. Now, what sort of data I can get from Shelly? Here it is. Shelly 3M uses the older API for MQTT. So if there's another MQTT API documents, but it doesn't use that. And one of the things that kind of bothers me is that you have to use precise topics like in here. You cannot just subscribe to an upper topic and get wherever. You have to just use precise topics. And those are the topics that are being configured that are basically give you information. So right now I'm harvesting information in here using my grid, which is Shelly 3EM. That's how Shelly EM3, that's how I named it. Emitter 0, this is channel 1 power, and solar is on the channel 2, so that's A, B, and C, it's 0, 1, 2. And that's how you harvest it. So I have my topic in here and that information. That information is actually provided quite often. If I'm gonna connect my debug node in here, you'll see that, where's my debug? You will see that it's already feeding every 1, 2, 3, like here. Every 3 seconds, I have a feed from that. So I didn't need that much information that would clog up my chart really quickly. And since I'm not storing it, I'm not bothered. I will use probably that frequency for the database, because that's gonna be all right. Hello, Alexi, you're right. Yeah, that's how often you get the data from Shelly 3EM, and it's great. So I have a smoothing node, which basically just returns a mean value and provides a little bit a better experience when launching this, and you don't need that granular data. But what I need to add consumption data, because right now I kind of see how much power I use per any given time, but I would like to have some NodeRED stored consumption data. Now there is a couple of things of doing this. You could supply that wattage information to your database and then use database calls to pull that information from bracketed range, and once you recalculate that for time, you're gonna have overall consumption. But that also, if you would do that, that would increase how many calls you're doing. Obviously, I can supply that data every 3 seconds, and every 3 seconds you can make a call to database getting the latest data, but it seems excessive. So there is a couple of things that Shelly has to help you out. It has built-in total energy used basically in watt-hours that is being stored, and I can grab that information every couple of seconds and update it in NodeRED, which is something I'm probably gonna do it. So let's grab that information first and see if we can display that as a number, because that's going to be quite easy to do. So what I have to do is just obviously get my MQTT topic, and my MQTT topic in here. Let's see, I want have total energy return to the grid in watt-hours. So that's probably this one, total energy in watt-hours. So we're gonna grab this topic here. I'm gonna go back to my NodeRED. Now, my name is slightly different. It's Shelly EM3, so we're gonna bear that in mind, because I don't use the device ID, because I only have one Shelly. And then for solar panel, it's 1, and for grid use, it's 0. So I'm going to get this one for solar panel and this one for grid. And that way I should be getting, I shouldn't name it, grid usage total use. Okay, let's do that. And that's solar total can't type. Total solar generation. Okay, cool. So if I just gonna hook up the debug not function, we're not ready for the function node. If I just gonna hook up a debug nog in here, you'll see that I'm gonna get some information straight away probably. So this numbers, obviously it's a current and it's cumulative, and it's from since I've started it. I can reset that timer if I want to. Ideally you probably want to have a timer running daily, weekly, hourly, and monthly in the LD. So you want that split between yours. And like I said, that can be done with a database calls, or you can just make it local. Now, if I want to grab this this data and quickly replace it and save it, I can get a let's do with a change nodes. I show you both ways of doing it. So for example, I'm interested in how much power I generated so far, and my message, I'm going to be setting my message payload, which is where the value lived, to a flow, let's say solar total. I'm gonna clean it up in a second. I'm just showing you how to quickly you can just store that information. So if I'm just gonna do this, and I'm gonna go to my flow here, you see I already have that information, and that information is gonna increase over time, and it's gonna be replaced. I don't know how quickly this changes. I'll have to see. Am I generating anything right now? No, I'm not generating anything, so that value will not change quickly. So let's go and do the same for total grid, so you could see this works. So that's a grid total. Okay, and this way I can get rid of that, and you'll see that in my variables I'm gonna have a second variable now. Come on, grid total. There you have it, and that's gonna be changing with usage. Sorry, it's this one. See 0.4. Maybe my computer isn't using that much. how much electricity I'm using? 400 watts. So in a second, that's all gonna update, and it will change 0.5. So those are your basic like counters, right? And you can take advantage of that and store it. So if you look at the API documentation, what else do we have in here? We have a command. So for example, if I wanted to reset that reset totals, there is a command in here that I can, well, this is a topic that I can just submit the commands to it, and that would reset that value. So it's up to you what you would do with it, whether you want to run it and calculate it, because there's more than one way of handling this. But you could just run a simple difference in what you've got over an hour. So for example, if I was making a calculations for an hour, I'd get that grand total starting every hour, save it, and then remove the grand total at the end of the hour, and I would have obviously a difference. There's more than one way to approach this. I could clear that value and start a new count and keep adding it. Or, because those values are not going to change very quickly, and I'm only going to be interested, let's face it, I probably would update this value every 10 minutes, let's say, right? So every 10 minutes I could save those two values to my database, and every 10 minutes I could make a call saying like, give me a data for last hour, give me a data for last month, for last day, last week, and whatever period you want, and update your thing. Now, one of the things that NodeRED also have is a new dashboard, which is really cool. I have a write-up ready, well, not ready, almost ready for it, but the dashboard has changed in NodeRED significantly for better. And if I wanted to display right now how much I'm using it, I could do it. And how I would like to display it, it's down to you. I could, for example, have a chart, but we already have charts. We can do a text input for now. Let's go as simple input, just not text input, it's just text. Let's do a simple text on my dashboard, and let's duplicate it. And if you just connect it this way, you're gonna have a very easy way of showing that information to my, it's not going to assign it to my dashboard. No, you just need to assign it to correct dash. Label text, so let's label it. So this one is grid total, and this one is solar total. And if I wanted to make it a little bit more pretty, I'll just get a nice little function node in here and change the payload to and add in in watt hours. It's in watt hours, right? So I could do this very simple way of adding a little bit of flair to it. Wrong thing. Connect it, deploy, and now my dashboard should have this information. There you have it. So we have one here and one here, so let's put it in place. So if we go to dashboard, we will be able to rearrange this into something a little bit more easier. Dashboard, where's the dashboard 2.0? Give me dashboard 2.0. Forgive me, I haven't yet. That's fine. There was this nice tool I could do. It's a group edit. Layout. See, it's been a while since so this is the layout for individual groups, and I want my that's not a dashboard 2.0. There it is. I was just like, why I cannot see it. So all I have to do is just drag this next to it. It's going to be at the top, and then if I want to edit the any features, I can use those in here. But now if I'm gonna just redeploy it, it's gonna just show where it's supposed to be showing. So those are my usage stats, but this is from the time I've enabled it. Let's have a look and see what else do I have in here. Obviously, over the time, I'll be able to monitor more complicated ways of that. Like I would like to see individual panel performance to see if my panels are needed replacing or cleaning, etc. So I don't have to climb the roof and figure out what's going on. So you will be able, like, I would be able to design my own dashboard that will say that information and produce information about how much electricity each panel produces, because you can do that easily. But that's down the line. What else do we have in here that is useful? Amps that we have. Do we care about how much amps we generate and voltage? We can get that as a reference. But that would be a very informative metric. I wouldn't be able to do anything with it. The idea behind this is that what I want to do with this, I want to have a rolling average of solar panels. I want to have like a cutoff in here and says like, oh, you're on peak power now, and that can be defined either by open weather peaks, or I can define that from electricity generation. And based on that, I can say to my home automation service, saying like, you can use grade A, B, and C devices right now in here. So if I have a washing machine ready to be set off, it will set off washing machine. I have a smart washing machine, I'll be able to set it off remotely. So for example, if I generate on average in the last 15 minutes, let's say 1,000 watts of power, so like, oh, do the dishwashing now, it's going to be fine. So this is what I kind of want to do. And the basic grading of how much power you generate, it's very simple. You can see it already on the gauge that I've set the gauge, the red in here to be my ambient. So if I'm covering outside of the range, it means that of the red range, it means that I supply more electricity than my house uses at ambient. The yellow is kind of like, oh, this is like, if you start using stuff, you will kind of probably run out of power and use the grid. And green is like handling more than, I think, 1,000 I used. Let's have a look. So current solar generation, 2,000. If I generate more than, 2,000. If I generate more than 2,000, then it's like I'm safe to run any appliances really without running a massive risk into taking a grid. Unless it's a kettle, then it's 3,000 and I'm a little bit screwed. But yeah, you get the idea. So that's how I would approach it. Now, apart from getting any information in here, you probably want to know what is going on weather-wise. And as it happened, I have a little thing that I've got in here for the weather. So that uses the weather information to kind of get me a basic weather temperature. So let's have a look and see what I have here weather-wise right now. Oh, that's solar. Sorry, that's the expensive one. I forgot. This one's it. Okay. So in here, I have information that would be quite useful. And the information that could be quite useful for me would be, first of all, cloud coverage. So right now you'll see that the 20% cloud coverage at this time, right? So I would expect to see my solar generation being impeded by 20%. Another thing that I would probably want to see, it's maybe a weather forecast. I can see that there's a clouds, there's a few clouds, so it's all right. So I can latch onto this and generate some sort of prediction or warning saying like, oh, this day is good to do stuff. Visibility then can play with it as well, because haze and stuff can decrease your how well your panels are performing. And sunrise and sunset information would also help me to calculate the peak. Now, if I'm going to look at here, you can kind of clearly assume that I'd say the peak time was from here. So that's, we're talking about 10:30 to currently till excuse me, till about 2 o'clock, right? With 1 o'clock. So that I would call it my peak solar time for the location I have and the way the panels are being oriented. There's a lot of variables for it, but I'd say that's my solar peak in here. And I would be looking between these two values today. However, my peak obviously is going to look much different in the summertime, because the sun is higher, the days are longer, and not only the peak is going to be just stretched out more, but you might also oscillate when it starts and when it ends. So this is quite important information. Now, I've mentioned in here that we could access the solar irradiance data. Let's have a look and see, do I get that in a free package? Let's go to API. So personal collections, this is where you want to look. We have current weather data, that's what I did. I can get forecast for the next 4 days, and I can generate all those information and store it in my forecast and use that. Can go 16, but honestly, with the UK, it's not going to be really useful. You can use solar forecast for the next day. Yeah, I've highlighted this early on in the stream because you have a solar prediction in here. But that solar prediction in here, if you go in here and you'll check the pricing, you'll quickly discover that, where's the solar prediction? It costs you 250 quid per month. But so we're gonna look probably solar irradiance and energy prediction, because I think this is in a free plan. Yeah, it looks like in a free plan, so I'll be able to get that irradiance. Later on, if I have a solar probe, I will be able to run it against the prediction and create, like I said, machine learning or something. So, hey, solar panel energy prediction, why is that different, or is it just, let's see, no, that's probably the same, isn't it? Yeah, okay, so I want this. I think this is on the free tier. And there's a pricing attached to it, and I think the pricing for this is going to be on 1000 API calls per day for free. So I should be able to get that information here. So no, that's in a special package. So if I wanted to use that, I would get a 10 cents per day, 10 cents per day, basic, because this is a prediction, a daily prediction. So you would have your outcome is, where's outcome? Not this one, this is the expensive one. I want to look at this, let's get the docs for it. And it gives you just data. So you can get a daily, and then it's a breakdown per hour of what you're getting. So at night you get not much, and then you get your radiation data that is being calculated by them. There is a BlueSky kind of, I think they called it algorithm BlueSky or something like that. Here. So there's a BlueSky and Cloudy Sky models for it, and you can get it for 15 days ahead. There's some historical data that you've got access to it, and well, you've got global coverage. But basically, if you wanted to run this daily, you would pay £3 a month for that service. Now, if you wanted to be less accurate and get that forecast, for example, every 2 days, because it provides you with a forecast for the next 15 days, then you would pay half that much. So it's not a massive cost, but then at the same time, I would have to verify how useful that data is and how accurate that is versus what I'm getting. So I could run it for a month or two and see if those values align with what I'm getting in terms of my solar generation. And if it's worth it, then that could give me a prediction of like, oh, tomorrow it's a wash day, or you know, stuff like that. Tomorrow it's a really good day for heavy appliances and or extra heating. So that is the kind of information that you could do. Pirate weather. It was a pirate weather. So what do we have there in an API? I'm checking if they have any solar information. Request parameters, response, longitude, offset, elevation, currently our ALS flare data points, temperature, cloud cover, so percentage, so that you get that in open weather anyway. What else do we have? Oh, fire index free, that's nice. I know the fire index is paid in open weather org. Let's see. Sunset times, temperatures. UV index would be also interesting, I think, because you could get the UV index as a metric of how much power you're getting. But I think you're getting for that for entire day on average rather than per hour. What else do we have? Yeah, we don't have any, I don't see any like solar specific things other than that. So I think like in a free packet, I don't think there is a much difference in what you get between those two. I didn't see irradiance data in either, so yeah, like, I mean, if you have a better source, obviously you can use it. But I feel like you're kind of getting a similar information for on the free tier plan on both systems. So it's probably worth looking. I don't know if there is any, let's say, solar panel generate prediction API. What do we have? Google Maps platform solar. Oh, where is this? Solar API from Google. So I actually didn't know about this. Let's see what Google has. Remote, isn't that just for placement? They have a, yeah, that's kind of, I think it calculates where you can put solar panels rather than where you can get. View the API reference. Find closes, get, not much here. it keeps switching me. Yeah, I think it's more about designing where you can put panels rather than anything else. So that's not going to be very useful. Solcast, Sol IP weather forecasting tool. The thing is, the problem is I don't think, I think it's going to be a lot of money trying to get you to give them money, which is fair enough if they like provide you with a great modeling data. But I think for very basic, because let's face it, I think that data is slightly troublesome, mostly because when you think about it, you can get really good real-life readings from it, but at the same time, you're already getting real-life readings from your panels. And with something simple like a random cloud obscuring your sun makes that data quite unpredictable. And while it may work on average in the long term, in terms of giving you a kind of a daily estimate what you can do, it's not going to be like very solid prediction to what you're actually getting. You can get pretty solid predictions about the temperature from the weatherman, because that's going to be kind of in line, and it's the changes in that are not as big. But with the solar data, it's a lot of factors that comes into play, and obviously that it makes it difficult. But as long as you kind of get a baseline of saying like today is a good day, which to be fair, you can just look through the window and say like, it looks sunny, it's going to be sunny, it's probably a good day to run my solar panel array a little bit better, then that's probably going to be good enough. And once you have batteries, that obviously it becomes less and less relevant to have an accurate forecast because your battery is going to save up that excess power anyway and allow you to use it when it's needed. So that's down the line. But yeah, but that's basically what I think. About it. Solar generation during winter, it's like, what is it, like 25%, I'd say, maybe 20% of what you get on a roof. Now, I don't know where's the peak performance on my panels. Like, they didn't look dirty on the video. Let me get the video for you again. So they didn't get dirty on the video, and I felt like, you know what, I have a close-up with them as well. I can put it. So they didn't feel dirty, they didn't feel damaged or anything. But I know I can get stronger panels, and the spacing I have in here would allow me to kind of space them a little bit better, and maybe add angle control if I wanted to. But I would have to see if that even makes sense, or if there's any significant improvement in generation. But like over the winter, like 1700, I think it was the top value I got. Speaking of which, how would we approach getting the maximum generation from a solar panel to see how much most we've been generating? Because you can kind of see it on the graph, but I'd like to have it as a figure. So we would have to get a, do we have a special node for it? Let's see, it would be a maybe filter. We could change range, check. Trigger, we could have a look. Okay, let's see those. Trigger, can we use something else for trigger? Send. No, that's not going to work. Filter. Block unless values changes. Great. Oh, that is what we need. We need a filter. So if I wanted to, no, this one. If I wanted to grab the biggest value and display it, so I'd say solar max, my add some units, so units are watts, and in here I would go block unless value is greater or equal, greater than, block unless value is greater than, compared to last valid output input, compared to the last input value. Now I would like, I think if I'm gonna set it to this way, it will record raising one, but then once it's gonna have a hike in here, it will override it, and I just want to stop it at the peak. So can I do it with, because I know how to do it with the function node, I just don't know how to do it with compared to the last input value, to the last valid output value. Do we have anything in a... The number of modes incoming value is the change greater or equals number of modes. Well, we can if we're gonna, my solar doesn't go anywhere right now, but we can manipulate the grid power, right? So we can check in a grid. So let's collect it and see what's gonna happen if I'm gonna do this. So yep, and probably gonna have to move that in a dashboard. Solar max, oh, it's already there, it's fine. So I have my solar max, and so obviously right now it shows the grid use. So grid use, now it should be staying. No, it's reporting lower, so I can't use it that, because it shows if it drops down and raises, it will keep the peak. So this is not the way to do it. Okay, block the value greater equal to, block the value is greater than. So an input value, let's have a look. Apply mode for each message. I don't think that's going to change. I think I will have to do it with a, so 98, yeah, it changes. Did I apply this? Yes. Okay, so I'll have to do it with a function node. So with a function, how I would approach this was, we can write it in this. So we need someone to store the value. So let's say like message payload. First, let's no. Current value. So that is mine, and we will, if current value is greater come on, it's greater than max value, then we're gonna update it, and we do that by flow set solar max value equals set to max value. Now we need to make sure that we have a max value, which we will pull from here. Max value flow get, and solar max value. Okay, so that complains because I don't think it recognizes it's not being assigned yet. We're gonna assign it in a second. There's a typo in here. Solar max val, and I need this in, I need this in this things. Come on. Come on, why cannot? Stupid prediction. Okay, so if our value is greater than message payload equals current value, otherwise message payload equals max value, and plus watts and plus watts, and that's basically how we would do it. And now to make it work, because it'll complain that we're not being set, obviously my because I'm doing it for grid, I need to go with a smaller one, because for solar would be other way around, right? And if I'm gonna go to my settings node, I'll have to, in settings, go on start and also set my flow set current. Come on, I can't type today, guys. Oh, why no one says that I didn't change the video, no one said anything. Okay, again, all right, sorry about that. So I couldn't do it with the other function, so I did that. So I have a current value which being set from the MQTT, it's here, and I'm gonna get the value from my memory, and then I'm gonna compare current value to the max value. And since I'm working with grid and my values are negative, I'm obviously gonna make it smaller. But then if this statement is true, I'm going to set a new solar max value and send that value to my dashboard. Otherwise, I'll just keep sending maximum value from the memory, and that's how it works. And in order for this to work, I need to go and create that here. So that's my on start, which is gonna have current, was it solar max val, and that's 0. So it doesn't return an error. So when I set it here, I'll have another solar max 0, and that should be updating as we speak, I think. I hope. Let's get debug and get information from it. I don't think I made any mistakes. 0 watts, 0 watts. What are we getting from grid? Why am I getting 0 watts? What values I'm getting in here? I forgot. And that's from solar. Go on, show me. So that's the minus, right? So if current value, because 0, it's smaller than max value, and max value is 0. Oh, it's not updated, 0, that's fine. That should be updating. If current value, which is now, and we're setting solar max value to max value, and max value is being 0 right now. Okay. Sorry, it's current value. If current value that was the problem. That should be now updating. Ta-da! So now we have, obviously it's light, it's not solar max, but you'll see that this is gonna stay at minus 396, even though this oscillates until it gets more watts. Now, if I was to force a little bit more watts, then it will jump in. What can I, let's turn on my printer. I've turned on my printer and you see the spike 422, and I'll stay at 422 even though I'll disable it. There, that's how you would approach the peak, the monitor what was the maximum. Obviously this will work for grid right now because my solar generation doesn't exist right now, it's in minus, but that's basically how you would do it. It's been an hour. Let's just quickly have a look. I just got a picture of my neighbor watching the stream in a car. That's great. I hope, Nick, you're not driving. But yeah, that's how you would do it. So let's get a pick so we can save the picks now. So I have this one for grid peak, and now grid max. Grid max, and then I can copy this and call it. And call it solar max. And then I'll connect it here. Then I can delete this one, duplicate this one. Why can't I duplicate this one? Call it a grid max. So grid max stays as it is, and solar needs to be changed to this. And I need to change the solar in grid. So this is grid. Done, and one more change, which is here. We need to go. Come on. Change it to grid. And that way, suddenly my dashboard has information about the maximum generation and maximum grid use. Yeah, that's quite useful statistics. They only took a couple of seconds to do. So we have total values. Those are going to do with the database. So I have an entire tutorial about how to use a Grafana and InfluxDB in here. However, I'm in the process of writing a new tutorial which I'm going to show you in a second about working with Influx 2.0 or 2. Whatever version it is, and NodeRED 3.0. Currently this is the state of it. So it basically outlines how to save everything, how to retrieve that data, query it. And one of the advantages of this is that you can go to your dashboard and you can look at your data from your buckets. For example, I have in here some measurements that I can just display. I don't know if it's anything saved right now. Test buckets. No, I don't have anything saved in that database yet. It's just a fresh installation, but you will be able to use that. And it's a new version in InfluxDB for storing home automation data. And it's pretty powerful because you can build your dashboards in here if you want to, but you can do your queries in here and create the queries that you can then use to query the data. And that's something I already have tutorials for, but like I said, this is a new version of it that goes with InfluxDB 2.7. And you'll be able to learn how to handle this, and it's a really nifty tool if you want to have your own database for this. So for like, if I was to generate that data from Influx, I'd just have like, or just select from beginning of the day to the end of the day, then I get a query on like using here how much data I want, aggregate it if I need it, and just copy and paste it to my NodeRED, and that information is going to be really easily available. And that works great for slow queries. So for example, if you have a queries that happens like, let's say once every 1-2 minutes, and you can write the queries really quickly, so you can, you know, have them written within fractions of a second to the database. That database is quite flexible. So this is something that's also coming up, and it's going to be part of that tutorial moving forward. What else we can quickly do in here? Let's have some tea, sorry. Peak time calculation. Peak time calculation would be use a weather. So if I, for example, wanted to dump my weather, current forecast, let's do that. Let's get a change node, and we can set my message payload. No, we want to set my flow to weather, and that is, we're gonna dump entire payload. So now, let's say I'm gonna run this every 1 hour. So now I'll have entire weather in my flow. And there you have, this is my weather. And if I wanted to calculate the peak times and stuff like that, I could simply just go in here. For example, let's go and do my peak time calculation. Let's start with inject modes and get the function node in here. And I'll get, let's get whole weather. That equals flow get weather. So, do we have a length of the day? No, we don't. I don't think we have as a... No, so we would have to calculate it. So my sunset would be this. Sorry, this. Weather data. My sunrise would be the same. And now, if I wanted to know time in seconds, this is seconds or milliseconds, I'll just do var day duration equals sunset minus sunrise. Arise. And then message payload equals day duration. And if I wanted to calculate that in days, I have a nice function in here. That's in Tasker, but Tasker uses JavaScript, and I can just rip the function. Where was it? Oh, was it here? There was a function that I had. I know, maybe it was in my other tutorial, because that's kind of what I mean, you can do it, but it's going to take a little bit longer. You know what? Let's be lazy. Let's be lazy. This is how you cheat. All right. All right. And get ra. This is where the ChatGPT is great for boring functions. Right. JavaScript function to change seconds into milliseconds, I think. Into days, hours, there you have it. All right, and this is our function. So I find ChatGPT to be great for stuff like that, because it's do I return here or do I return, because okay, let's do the whole return and see what's gonna do. I think I'll have to modify this, but okay, many functions. So that's convert to milliseconds. Okay, I think this is milliseconds. Yeah, I think that's milliseconds. And I should have a debug in here. And now when I run this, I'll get time in 30. What? That's in seconds then. Okay. That was in seconds, I think. Okay, fine. I know what to do. I just don't want to type it all on the live stream, because that is not how things should be doing, and I hope that's gonna work. 8 hours, 23 minutes, 52 seconds. Hey! There you have it. ChatGPT for the rescue. That's how you nicely use ChatGPT for boring stuff. Now, I wouldn't trust ChatGPT to do everything I did today, but like if you just want a simple function that has been probably done over and over again, you can search for Stack Overflow, but ChatGPT works for it quite well. Okay, so yeah, now if I want to write this in my dashboard and get another information from the dashboard 2.0, for example, I would get a I guess text again, and probably that needs to be formatted into something nice, because right now if I'm just going to do this, I wonder how it displays the object. I haven't tried with the object, but we can try it, isn't it? Yeah, it doesn't handle the object, so I need to format the data a little bit more. So my message payload, I get a array, array JavaScript object. So I would just do time, and then equals to day plus day dot day. If I remember correctly, that's what we had. And then plus we need minutes. So that's days actually, maybe. Does it say days in the data? Or days, it says days in the data as well. So days, days, cool. And then we just need to add minutes. Minutes and then hours, sorry, okay. Oh, I'm not typing. Why am I not typing? Oh, I broke something. My Chrome didn't something went wrong. Okay, let's see how much I lost. Yeah, all of it. Okay, let's do it again. Day. And then my message payload equals to days plus day dot days plus come on. Hours, and we need like this, and then hours, and then minutes, and then seconds, okay, and then comma space for formatting, and I think that should display nicely. Do you think it's gonna display nicely? I think it will display nicely. Hours undefined. Hours, I can't spell. Hours. Should that display nicely when I pick in here? There you have it, and that's your day duration, which is nice. Solar Assistant MQTT Open Hub for this, and I'm very happy with it. Awesome. From that, if I wanted to now calculate the peak to be a fixed amount of time, so for example in here, I could say I want to narrow down the separate, or like calculate what I could do then. Based on the time, calculate that my peak time, I'll say this is a 25% of a day. So in here would be like just 4 hours, let's say 4 hours, right? So then the duration, as the duration increases, my peak would change. The duration would be of the peak longer, and also the start of the peak would shift. And then what I could do is calculate how much power I'm getting in a peak time, what's the maximum I get, because I already know how to do the maximum, right? And what was the total amount of generated power, so I could calculate how long I could use my devices for. So you can do stuff like that. And it's nice to have dashboards to look at it and saying like, that gives me a bit of information. But what's nicer is to process that data in a way that is actionable, so you can use it for something. Because generating the data for the, to look at, it's all good and great and kind of impressive when you want to show it to someone. But at the end of the day, the important bit is why you're doing this. Like what are you going to do with this data? How that data is going to serve you. If you're just going to look at it, then it's like, okay. But if you can format the data into chunks that you can use for something as a trigger or then this has become much more meaningful because it's more interesting. So my plan is to calculate the peaks, calculate how much power I have, and based on how much wattage I get, so the solar max and the average, rolling average for electricity generation, to enable heating in specific rooms in order. So I'll have a queue saying like, okay, let's say between 3 o'clock and 4 o'clock, I want this room in here to have the heating preheated. I'm not home, but I want this room. But if I have excess power, I want this room and my living room to be preheated. But if I have even more power, I want 4 rooms, etc., etc., etc. Now I'm doing this because I don't have a battery and I can't go home and press the button and heat up the separate rooms. But I can take advantage of the fact that I still got that lease and make sure that the company doesn't make a penny out of me. I hope they don't watch this. But yeah, that is the kind of plan. All right, I'll leave it there because I kind of planned 1 hour 30 today to kind of mess around with things and show you what I'm doing. Hope you enjoyed that sneak peek. Obviously, that's going to end up with a proper tutorial. And it's going to look much nicer than what it is right now. I'm just messing about and just sharing the ideas of what I want to do with my solar panels. But that is just one portion of it. Today I'm also connecting heating to another relay, so I'll be able to finally control it remotely. It's been like 2 months and my heating isn't on. But then it's all gonna go to pants again because I'm gonna have new radiators installed. I also did this, let's have a look, I'll show you. There's something I've been working in the background. Providing it's gonna open. Let's switch the screen while I remember. Oh, interesting. It's not showing the screen. Let's try again. Maybe it didn't load. Is it not loading now? Yes, it does. Okay, so in here I have my home. My home and the plot of land, and everything is kind of in the millimeter accuracy right now, including window sizes and door sizes and everything. But that is basically the layout. It's quite interesting to see because you can tell where the extension work has been done. So for example, so this is the front. And you can see that in here, that was extended. That used to be a front of there was a garage in here, so that was extended. You can tell that from how big the walls are. And yeah, every room in here is a separate entity, and I can just disable stuff. This is my layout underneath it. So this is entry, this is living room, this is my workshop, this is pantry, this is a utility. That's kitchen and diner and conservatory. There's a small toilet, bike storage, and a corridor. And first floor. So right now, currently, we are in this room here. This computer is in this corner. There's a bathroom, second bathroom. There's my YouTube studio. This is my master bedroom, and there's a spare bedroom I'm using as a master bedroom because bedroom is being worked on, and corridor with some stairs. And that's a walk-through wardrobe. I'm going to make some changes. I want to get rid of this and get rid of the bathroom and create that into a YouTube space with a different section of studios, and just have this as my master bedroom. But yeah, I'm basically replicating an entire CAD, my house in a CAD, and it's gonna be quite accurate. You can see that to the point where I am going to be adding electrical outlets and electrical lines, so you can then later on plan your work in advance. So it's going to be quite fun. So that's something I've been working on. Yeah, so there's a lot of interesting things that I'm working at the same time. The time is the biggest problem right now because I feel like it's quite difficult to kind of manage everything between the full-time work and YouTube and house renovation and whatnot, and having a spare time just to myself. It becomes problematic sometimes. So yeah, but good things are coming, and they can be coming quite soon. And I'm now off to shoot a video for release from Switchbot. So I hope you're looking forward to this. I usually at the end of this stream tell you what I've got for the next videos, but there is a lot of NDA stuff which I can't talk about, which is like, can't share this yet. But yeah, the exciting things are coming. I hope you subscribe to my YouTube channel and see all the shorts, because they contains the stuff I can actually show. And all of that stuff is coming soon. So, right. No, see that? This. That's from Switchbot. Right, guys. Thank you so much for sticking around. Thank you so much for watching, and I'll see you quite soon in the next video. And I'll be doing more live streams. I've got a couple of fun stuff that I would like to do on live stream on a regular basis, including repairs. I want to do like I don't know, maybe on Friday evening, an hour or two where I just take a random thing and try to repair it because it's broken. I think it could be quite fun to do it. I need to do stuff like that anyway, because there's a couple of things that need maintenance, and I think it would be fun to do it together. Maybe I'll get some pointers and help from you, or maybe you'll learn from me. So I was thinking about doing that to kind of get into things live streaming, and you'll see live streaming for NodeRED more. We're actually like getting heavily into NodeRED sessions and actually doing the house automation, because honestly, I do not have a single automation right now, which is annoying because I did a very dumb thing. I accidentally left my hot water shower running for 8 hours. I returned to the bathroom terrified because the condensation droplets were this big. And the biggest problem of it that I have is that I actually have a temperature and humidity probe in there, which with a logger, and collects all the data. It just doesn't send it to my server because my server doesn't really exist yet, because I didn't have time to mess it up. And in my old home, I would get a notification saying, hey, your bathroom is a bit weird, but I didn't. So I spent half an hour just wiping condensation from pretty much everything, hoping that my plasterboards are not going to swell and explode. So that didn't happen. Unfortunately, that didn't happen. But I'm not looking forward to my electricity, to my gas bill this month, because, well, that's an expensive shower not to have. I hope your homes are doing better. Right, guys, thanks so much for joining me today, and I promise to see you really, really soon. Take care. Bye.